So about the OSI model and TCP/IP model. So actually in networking, we use these two models, and it's a logical model. It's nothing like a physical thing. It's a logical model, and we use these models as a reference for us to check the behavior of our nodes. And OSI is the old model, but still, whenever two network engineers discuss, they always refer as a OSI model only. Let's say if somebody is saying layer 2 having an issue. So this normally means there is an issue in a switch or their MAC address. But if you go to TCP/IP model, so they have a layer 1. All this thing they enter there as a layer 1 part. So OSI model is the old one, but still it is very relevant one. But TCP/IP is the new one. So and both having something similar and some are differences. So first difference will be like OSI is a 7-layer model, TCP/IP is a 4-layer model, and somewhere it's mentioned as a 5-layer also. So both are correct, 4 or 5 layer. So normally it's a 4-layer model they consider as a per vendor documentation point of view, but somewhere on a net it considered as a 5-layer also. So let's see the OSI layer model first. So okay, so before we move to the model, so first thing is why we need a model actually, why we need this thing in a network. So these model we required so that there should be some standardization, because we have multiple vendors, like we have a Cisco, we have Juniper, we have now Nokia, we have other companies also coming, ECI, Ciena, and many more are coming nowadays. But why? So these all will be our gear makers, means they will create our routers, some create switches, some create access layer routers. So to have common standard, because customer can use, like a service provider can have a multiple vendor router, they can have a Cisco, they can have a Nokia, they can have a Juniper. So we want them to be on a same platform. So what we can do, we created one model, so all these gear makers need to be follow that standard document. So that's why we have a standard, and we come up with these OSI layer and TCP/IP model. So this I just example, like if let's say one is Dell PC, one is Mac, which is Apple, and they have a different standard. So in that case, they may not be able to communicate with each other, but we want to share a file, we want to share some information, so then these all should have same type of information. Okay, so OSI model having a 7 layers. So these are the 7 layers. We will cover each one by one. So first is physical layer, and means this first 4 are more relevant from the point of view of network engineer, and rest 3 are more towards the development side. So developer will work on most of these 3 layers. Okay, so from a network engineer point of view, we are mostly work on these 4 layers actually. So first is physical layer. In physical layer, or all the fibers, copper cable, so all these are part of our physical layer. Our wireless, like sometimes we have a microwave kind of connectivity at the last mile, or satellite connectivity we have nowadays coming up. So these all are coming in the physical layer. Okay. Then we have a data link layer. So in data link layer, we have all the L2 related devices. So L2 layer devices like your switches are there, which are part of only L2 switches are there as a part of data link layer. So which work on the basis of MAC address. So these will be act as a data link layer. Now we have like MPLS kind of technologies also coming up. So which is having both kind of means L2 plus L3. So that's why we keep them as a 2.5 layer, which normally say for MPLS. But in MPLS also some of the L2 services are there which work on data link layer. Then we have a layer 3, which is a network layer. So in network layer, we have our routers, like all which work on IP addresses. So all will come into a picture of routers here. So routers will be like your means any vendor's router here, and then MPLS again will become here, because it will also work on IP addresses. So we will have a routers here. Or a layer 3 here. Then we have a transport layer as a layer 4. So which will be our TCP UDP will come as a part of transport layer. So these are the protocols which work on transport addresses actually. So from the exam point of view, they normally ask, like they give you some protocol. Let's say they say TCP work on which layer. So like that kind of options you normally have, or they will ask you routers work on which layer. So these kind of thing they normally ask, or other way around also they will say on network layer, which of the followings are work, like router, switches and all. So you can select that correct option. So from the exam point of view, they can ask this kind of question normally. And then we have session layer, presentation layer, application layer. In TCP/IP, this all is combined as one layer. So in this, we have 3 different layers, which is normally from the browser point of view, as a developer will work on it. Session layer is like it maintain different sessions on a browser. Then presentation is how it will present your English format to the machine in a binary format, and binary format to in the English format, like how it will present your sessions there. And then we have an application, like whatever you open on a browser, like HTTPS or gmail.com you are opening, so that all are your applications. So this is a nutshell of the OSI layer model.
Okay, do some switches work on layer 3?
Yeah, we have nowadays, because OSI is a little old model. So at that time, we don't have the L3 switches, at these kind of concepts are there. But later on, these all also coming now. L3 switches are there. So these are like L3 switches work on now, because it's work on IP addresses. So it will be like network. If it work on your MAC address, so it will be on layer 2. So like that. But if they mention normal switch, so you have to consider it as a layer 2. In an exam, if they're saying switch, so it is layer 2. They specifically say it's a L3 switch, then you have to consider it's a IP address related something they are talking about. Okay,
thank you.
Yeah, so in application layer, what all protocols we have, like HTTP, HTTPS, so these all are protocols. So it's like this layer is closer to end user, means because whenever you open your browser, so whatever you do, or you open the HTTPS, any web page, so it's a application layer on which you are working. So this kind of question they may ask, like when person is working on a browser, so on which layer they can ask, so on which layer it is working. So this kind of thing they will ask in a exam like that. It interact with software application like web browser, Firefox, Chrome. These all are our layer 7 devices. So functional layer 7 include identify the communication partner, synchronize the communication. So this all, like yesterday we discussed, like when you open, it will convert that English into a DNS format. So all that is a process, but application layer is only browser which you open, and on that you open the HTTPS page. So that is the only part of application layer. And we don't have much work on that side, because it's like a browser is basically taken care by the person. Then we have our application layer. So application layer, it's like it's a direct, means in between, let's say these are 2 devices. One is your PC, one is the server on the other side of, let's say, YouTube server. So whatever you will work here, it will be like same layer interaction, means your router or your ISP will not able to open that information. So it will be like, it will send your interaction will be, application will be sent directly to your server side, and server will only understand what is your requirement, what content you are looking for. So it will only share you that information. Okay, and layer interaction will be adjacent. So application layer will send a packet to the presentation layer. Okay, so presentation layer will, what it will do, it will just convert into a correct format which will be understandable by our machine, means your laptop or your server. And same way, when packet will came from the means downside, from the other side receive on the server side, so it will again convert it back to the format of the browser, which browser will make it translated again. So it just work as a translated layer. There's nothing else on presentation layer you will work on. It will translate to different format to be sent over the network, and presentation layer job is to translate between the application and the network format. So this is the only work of the presentation layer. Okay, so second means third layer is session layer. So it control the session between the communication, establish, manage, terminate. So this all part, like between web browser and your remote. So this is the only function of your session layer. It will manage your session between your end-to-end host, you can say, from your device, your laptop to the server. It will just manage your connection here, and it will decide whether you need more information, so it will terminate that connection. So like that thing, it will be a part of session layer. layer, but this all session layer, presentation layer, application layer, all will be part of your browser. So browser will take care of all this thing. It's like what code or what things are going on in the browser, so that will be taken care of here. Now this only we mention here, network engineer don't usually work on top 3 layer, application developer work on with top 3 layer OSI model. So normally you see very rarely you will, sometimes they ask question from the application point of view, but rarely they will ask from the first 3 layers. Mostly they focus on these 4 layers of the model, because we usually work on these 4 layers. First thing is like that this is a packet data unit, so just remember these units there. Okay, so first thing is when the packet pass through these 3 layers, we call that packet as data. It's a data till the point it reach to transport layer. So data will be added with the transport layer header here, means whatever the information or protocol you are using, whether it's a TCP or UDP, so that header will be added there. So data plus header, we call it as segments. I have a slide for that also. So data plus header is a segment here. So what's the role of the transport layer? It segment and reassemble the data for communication between the endpoint. So basically, let's say you have some big data, it's an internet data, it's a very big file you are sending. So transport layer is the one which has this function. It will maintain your session. First of all, like it will create the segments like your data. It will add the header of the TCP or UDP, whichever protocol required, and then it will decide whether this big segment I can send it out, or I have to break that segment into a small pieces, so that it will get fragmented, and you will again reassemble that on the device, on the receiver end. So transport breaks large piece of data into small segments, which can be more easily sent over the network and less likely to cause a transmission problem. So it will work like that. Sometimes we have a voice kind of traffic, which is very small packet size of voice traffic, and it's very sensitive traffic, because let's say you are open some internet YouTube video, for example. You are seeing the video. Sometimes your packet may get missed, but you will again receive a packet after some seconds, so it will be fine for you. Nothing, you will feel like, okay, I have a slow session like that. But if it's a voice call you are going there, so it's a real-time kind of traffic which we are talking right now. Let's say it's a real-time kind of traffic. So if there is a problem with the signal or some problem with the internet, so you will feel like you have some disturbance, or person voice getting distraction, means you are losing the person in between. So that kind of traffic is more sensitive for us. So there it will not do the break this into small pieces. But when we have an internet kind of traffic, which is very large traffic can be, so then it will break that into a pieces, and then it will send the packet out, and on the far end it will reassemble that packet once it receives there. So here I mentioned, once you have an actual data plus your header, you have a segment. Then we have our network layer. So it's like once you have received the data plus you L4, till this point we call it a segment, and then we will add a L3 header. L3 header is your IPv4, IPv6 address header we are adding here. So this will become a packet here. So now IPv4, IPv6 header main role is like it's a logical address. So once you have to send the packet out from your local device towards the ISP routers, so this address will only help us. It will only understand where is the destination, how I need to route the packet out from my network layer. So that is the role of our IP layer 3. So here I mentioned here like data plus L4 plus L3 header, and it's a packet. Okay, and when we have a data link layer, so it's like data plus L4 plus L3, and then we have L2 header and L2 trailer also. Only this layer have a 2 header plus tail. Other don't have any tail, but this data link layer have a tail, and we call this whole as a frame. Okay, so this is a call a frame here. So frame is L2 side, where we will add L2 header will be your MAC address, will be getting header, source and destination MAC address, and Ethernet header you can consider here, Ethernet layer which is working here. And tail is your FCS. FCS is something which will decide whether your packet is error free or there is some error when you transmit it from one location to the other location, or one host to the other host. So it will decide whether the packet is getting some error or not. So it will decide whether L2 trailer or it's a FCS error we can normally say here. So data link layer is the one which will be having node to node connectivity, like PC to switch, switch to router. So it will be the one which normally change whenever you transfer from one device to the other device. So let's consider example like this. So here you have one host, and then we have routers, and then we have host B. Okay, so these are three hosts, and in between you have your, let's consider it's a ISP routers here. So this is your laptop, this is the destination side server. So host will, what it will do, it will say, okay, I want the information for w.fb.com. So whatever the fb.com content just present for me, it will just send that packet out from the router. Router will not able to see what information you actually require. It will only see your first it will say, okay, I receive a packet, is it a valid MAC address for me only, or is it for some other device? So it will say, okay, I receive a packet with valid MAC address of my node. So it will just means it is checking the L2 here, L2 layer, and then it will check the destination IP address, which is converted through a DNS whenever you open w.fb.com. So it converted into IP. So router will check that IP address, and it will say, okay, I have an IP address, I will just forward that packet out. But it will keep the IP address of the destination also same. It will not change that IP address, but it will change the MAC address. Now means your layer 2 header will be changed here. It's a different header will going to be added. So like that your flow will be created. Let's say this is your laptop. Okay, your laptop is obviously connected with internet. Okay, so this is your first router. Let's say from internet point of view, this is your first device. Okay, then you have another device which is connected with your destination site. Let's say there's two laptop, one is mine laptop, other one is your laptop, correct? We both are connected through internet only, right? Currently I am also connected through internet, you also connected to internet. So in the internet also we have a devices there, right? There will be multiple routers, because we both are sitting in different location. So there will be multiple routers. So consider this is first router from your side, and this is the first router from my side. Okay, these are two routers. Now you are saying, I want to open, let's say for example, let's say you want to say, I want to open a ping packet. For example, you want to ping my host B, my laptop. You are saying, I am doing ping 10.10.10.1. This is my packet, I want to ping it here. Host will say, okay, is 10.10.1 is the packet you want to send out? Okay, it is only reachable through this router link. It is a link here. So it will say, okay, destination IP address will be 10.10.10.2, which is the host B IP address, and host source IP address is 10.10.10.1. This is my source IP address. Okay, now it will say, okay, this is the layer 3 information I added. What about the layer 2 information? Because in OSI layer we need all this information to be get added. So it will say, okay, what about my layer 2 information? So it will say, okay, layer 2 information will be your MAC address. So MAC address, I know my MAC address, which is the local MAC address of host A, but destination MAC address is not about host B MAC address. It is a MAC address of this router interface. This router, whatever the MAC address here, so that MAC address will be added on in my packet, in my first packet. Okay, so difference is IP address is of destination host B, but MAC address is of local connection only. It will not of destination host B. So once your packet reach to router, okay, now router will say, okay, I receive a packet with valid MAC address, it's for me only, through MAC address. I will remove that MAC address because I need to check the IP address now. So I will remove my MAC address packet. It will remove that header there. It will check the destination IP address. It say, okay, destination IP is of host B. Okay, I understand you want to send a packet to host B. So host B, it will check in its routing table. It will say, okay, I know the address of host B, how to reach it. So it will send a packet out again from router 1 to router 2. But here the IP address, it will not change. IP address will be host B as a destination IP. Source will be host A only. It will not change that packet. It will keep that packet as it is. But it will change the layer 2 packet, which is of MAC address packet. It will now add a MAC address of router 2 as a destination and router 1 MAC address as a source. Okay, so this will be changed here.
What layer does it do that on layer 3?
On layer 3 it will not change, because it is saying I mean, let's say if we change the MAC address, IP address of the source, let's say it's add a source IP address. So host B will consider this request I am getting from the router, not from the host A, if it change that way. So it will keep that information as it is, so that host will be make it aware like this information is not coming from the router, it is coming from the laptop itself only. So that information will be as it is, it preserved by the router, and it will send it out. It will just look into that information and decide which interface, because router normally have a multiple interface. Here I am showing only a single connection, so it will have a multiple connections. Through this information it will only check where I need to send a packet out. So that's why it will preserve that information of the IP address, but it will change the information of the your MAC address, because MAC address is a local interaction only. Host B don't going to check that part. It will only verify, okay, its packet is for me, that's okay. But if it need to reply to that packet, it will reply on the basis of IP address here again. So IP address we will keep it preserved throughout our process.
Okay.
Okay, so this is a flow we normally keep. Let's go back again. So we have reached till frame. So this is how the frame will be. So these are packet data units. So remember these at layer 4 we call the data as segment, because it will data plus L4 header, and layer 3 we call data L4 L3 as a packet, and layer 2 we call it as L2 header plus L2 trailer as frame. So just remember these are packet data units, just we need to remember this part. And then we have a physical layer, which is like your connection. Physical connection can be your wired connection, can be wireless also. Both are considered as a part of physical layer. So here you will convert your whole data in form of electrical signal, which we call as bits. Right? When you send a packet out, it's not actually English or your machine language going out. It's actually a converting in the form of electrical signals. Normally, if you see this cable, your fiber cable, if you connected that fiber cable now with, let's say, one side you connected with the router, for example, and if you check from the other side, you will normally see one light is coming out from that fiber. So that means your link is through. And if you connect that other side also with your with some device, router, switch, or let's say laptop, for example, so you will able to communicate between the two. So your connection will be some kind of electrical signal it will go through, and we call it as bits, and bits is going out from this side. So this is data unit. You can just take a screenshot something, or just remember this, because these are normally important. They normally ask question from this side, like data segment, and this is a protocol data unit, data segment packet and frame, and then bit. And remember the sequence also, because normally the sequence they say data segment packet frame bit. Okay,
Got it.
yeah. So to remember the OSI layer, these are some acronym you can use. Like all this application, all people seem to need data processing, or acronym pointless, student teach not do, please. So means I don't recommend to use the acronym, but if you want to remember, you can do it. More you practice, the more you will remember these. These are very simple terms. Normally in day-to-day life, every network engineer use these kind of terms, like there's an issue at layer 2, so we normally remember layer 2 means data link. So like that thing. There's an issue in router, issue at layer 3 level, so we say it's a network layer issue. So these are the terms you can remember that.
Okay, I got that one.
So now after OSI layer model, which is like an old model, now because we have a different kind of protocols coming, different kind of hardwares coming, like you mentioned, layer 3 switches are also now available. We have MPLS kind of protocol, which is not part of actually L2, not part of L3. We have BGP kind of protocol, which is working on port itself, TCP port, and then on top of it we have a protocol. So it's like layer 4 plus we have a protocol. So this OSI layer model is not actually relevant with nowadays with protocols and the gears we are making now here. So they come up with a TCP IP model, which is actually a little old model again, but it's earlier only for defense purpose for United States. Later it make it for the public also. So what's the difference between the two models? This is more relevant thing. It's like OSI model will have a 7 layer, it has a 4 layer. So what they did is they make this application layer as a single layer because it's all is a part of one single browser only. So they make it as a simple application layer here. Transport remain as it is. In network will become internet, and again in data link layer it become a link layer here. So in somewhere you will see data link plus physical, again it will be part of this model. Again it's a 5-layer model, somewhere it's mentioned, so they keep these two as it is also, but normally it's a 4-layer model, and it they mention, and it's like application layer will have their transport, internet, and link layer. Okay, so this is the difference. Functionality wise all same, but the role of transport layer same, it is both side. Network layer it's like IP address, both will be same here. Data link layer like your L2 and physical cable, so same will be relevant for link layer also, so it's the same thing. So that's what I mentioned also, like you can see where in some online it's 5 layers, so 5 layer the only difference is like data link and physical they only added there, otherwise normally keep the link layer only. Okay, so this is a flow which I already explained. So this flow you understand now, like how the packet actually flow there. So you have one side you have a host A which have all these layers there, host B, we have a connection through Ethernet, and then you have your routers. Router don't have all the 4 OSI layer model need to work on. It will only work till layer 3 because it work on IP, so layer 3 only it work on. So like this flow actually happened. Yeah, you are asking some question?
No, I understand.
Okay, good. So let's go through the quiz first. Okay, so we have 4 or 5 questions, so let's try to answer that, and then you will again memorize this part. So let's say you are at HTTP data sent from the YouTube web server is displayed via YouTube web browser. This is an example of what? So means you are opening one YouTube HTTP data on your browser, and you want to open, you want to send the data to the YouTube web server. Means there's an interaction like from host A to host B, and with your laptop and with your server. So this type of example is for which layer? Is it like adjacent layer interaction? It's the same layer interaction, encapsulation, decapsulation. What is this part?
It's either C or D. I think it's D.
No, it's a B actually. Same layer interaction. Huh? Yeah, because what we are doing, it's an application layer, because we mention here a browser here, right? We have a browser. Then we are saying we want to we are opening some HTTP data. Like I mentioned, HTTP data we are opening on browser, and so our router and other device will not able to interact with each other. Interaction will be directly by your server side. Server will only able to open the data. So it's a same layer interaction. It means application layer will only interact with
HTTP.
We on HTTP, which is the layer 7 part, and our router obviously not able to understand the layer 7, it will understand the layer 3 only. So your server will only interact there. So server will understand the layer 7 here, and it will only then only because it will understand the layer 7, then it will see what content you are looking for, which video you are looking for. So then it will give you a reply there. So it's a same layer interaction. So second quiz, it's a HTTP data has been encapsulated. Your data getting encapsulated with 3 separate headers, right? We see the headers there, and one tail also getting added. What is the appropriate name of this packet data unit? So we have a separate header, 3 separate headers, means layer 4, layer 3, layer 2. So these are 3 headers plus tail also there. So what is the name of that data unit? We call it packet segment frame data.
The frame?
Yeah, correct. It's a frame. So it's a layer 2, for which they are talking about, because they added a 3 header here. So 3 header means one is your actual data, then we have a layer 4 as first header, then we have layer 3 as second header, and layer 2 as a third. But our main hint is one tail. One tail is only available at layer 2 level, so which is frame. Okay, so this kind of question they normally ask. Okay, which layer of OSI model are most relevant to the role of network engineer? Means transport layer, data, network, physical. It's from the TCP IP model they are asking from. Transport, network, data, network only, application presentation, session. So which 4 layer you consider as it from network engineer point of view we normally work on?
Is it A?
Yeah, correct. It's A. Transport, network, data link, physical. So second last one. So the link layer of TCP/IP model is equivalent to what layer? A layer of OSI model here. So means link layer on the TCP/IP model, which is last layer, I will say from the first layer, sorry, from the TCP/IP model, is equivalent to which layer of OSI model? Is it data link layer, data link plus physical layer, network layer, data link layer, transport or network layer?
Is it C?
No, it's a D. Link layer,
D.
and we have a 2 data link plus physical.
Right.
Both will be as a part.
Okay.
Then we have a last quiz. Which layer of OSI model provide host-to-host communication? Means between two hosts only, we are directly communicating here. So it's like we are communicating. Application layer is like same layer of interaction we are doing. Network layer is like we are doing interaction here, like means you are on the base IP address, so you have an interaction with your routers also. So transport layer is like your TCP UDP, and which is again two hosts are interacting here again. Then we have a data link layer. So which one will you consider here? Application, network, transport, data link. Yeah, correct. It's a C, transport layer, because TCP UDP is a protocol which create a session with the end host only. It will not create session with your intermediate routers or switches there. So end host will only have create a TCP session. Once this TCP session will be established, after that only your actual data start transmitting, right? So we will cover that in TCP UDP part also. So this is how the OSI layer works. Fine. Is it interesting, that quiz part?
Yeah.
Okay. Okay. So this is Cisco CI. This is not relevant for us. Let's move to Ether channel. Then we will move to a packet tracer part. We will take after that 15-20 minutes break. Then you can connect to a laptop. Okay. So we will see how the layer switching is actually working. Yeah. So like we cover the transport layer, everything OSI model here. So now we have to cover like data link part, how actually this all layer data at data link part of L2, how the MAC address I explain, like this router will send a MAC address, it will change the MAC address table, but actually how it will learn the information, like which MAC address I have to add and where I have to send the packet out. So that information we will cover in this chapter. Okay, so this is a packet data unit. Just for a reminder, data segment packet frame. So L7, this is first three layer, L7, L6, L5. Then we have L4, L3, and then L2. And last we'll call bits. Normally that is not considered here, so it's called bits. So these are called packet data units. Okay, so this is an Ethernet frame which is work on L2. Whenever you pack it out, so like I mentioned here, at layer 2 level we have a frame. Frame will be added with a Ethernet, one tail part, one header part. So what information actually in the header? It's like preamble, SFD, destinations, MAC address, source MAC address, then what type of this information, and then we have an error, checksum error, just to identify what is the error there.
And that's on layer 2, like all of those.
Yeah, it's a layer 2. It's a layer 2. So means this part we are covering here, frame, layer 2, L2 header part we are covering, and L2 tail part only. L3, L4 we are not covering here. Only L2 and L2 header and L2 tail part we are covering this step in this slide. Okay. So preamble, SFD, destination, source, MAC address here. Okay. So what is the role of this preamble and SFD? Preamble is something you can say it's a gap. Normally we keep. Let's say you send one packet. Before sending the second packet, there's some gap is between the two packets, so that is considered as a preamble. There's a preamble bit we consider. So it will allow devices to get synchronized. Okay, it will say, okay, first packet completed, now second packet is coming from me. So that is the role of preamble only. And say SFD is like it is saying, okay, preamble bits are is finished. Now next bit will be after my bit. Its next bit will be my actual data is coming now. Means with the header it is included there. So it's saying with the header my actual data is now coming after this. So this is the role of two preamble plus SFD bit. And normally we don't consider these two as a part of the header there, but these are actually exist there. So just for for the knowledge purpose, you can remember these preamble and SFD is always there, but normally we don't consider as a part of Ethernet header these two. Because I remember one time they asked this question like preamble, how much is the, what is the bits for the preamble, how much is the size of the preamble. So that's why I included this part. One time they asked this question. So this is a 7 byte and this is a 1 byte only. Okay, so 8, if they are in a bits format, so it's 8 bits and 7 into 856. So this is a bit format. Our main is like destination source, which is a MAC addresses. So it will be include your destination MAC address of the device, source MAC address of the device. So this is a 6 byte only for the both sides. Each is 6 byte. Destination is 6 byte. Source is also 6 byte. Indicate the device sending and receiving the frame. And so like the role of MAC address is like it will identify which device I have to send and from which device I am sending it. Then we have a type field. Is 2 byte. It's a value of 1500 or less than field indicate the length. So it's actually defined what type of packet it is coming there. Is it a means ARP packet is coming there, or is it a IPv4 packet is coming there, IPv6 packet is coming there. So I will show in this Cisco packet tracer also how actually this all field we can see. I will show that also, but just for the theoretical purpose I am showing it in a slide. Okay, so this is your L2 header which we are talking about. So you just remember 7 byte, 1 byte, 6 byte, 2 bytes, and this is FCS is also 4 byte here. So if you add up total, it is like 7 plus 1 8. It's 16, 20, 22. Here it's 22 as a header here, but we don't consider these two as a part of header. So you can minus 7 and 1. It's like 8. So if they ask what is the size of the L2 header, so normally we have to mention it's like 14 only. 6 plus 6, 12 plus 14. If they say what is the size of L2 header plus tail, then you have to add the FCS also. FCS is 4 byte. So it's like 6, 6, 12 plus 2, 14. So normally it's 14 byte without VLAN. If they're saying it's with VLAN also, then it will increase there. I mean, normally they don't ask this typical question. They normally say like what is the size of L2 header. So it's a 14 byte. Okay, so FCS is like your last tail hand. It's a 4 byte inlet, and it will detect whether it will do a CRC algorithm. It will run. It's an internal algorithm just to verify whenever you are transmitted the packet from one host to the second host, there will be no change in the packet, or somebody didn't corrupted that packet, or it got corrupted because some error in your physical layer, your SFP is having some error, port having some error, so it's not getting corrupted. So this is the one which will verify that part through FCS. It will run a CRC algorithm. So it's a total, it's a 26 byte header plus tail, but because we don't consider these two, so just consider it's like minus the 8 here. So with both it will be like 18 bytes here. And if they ask only header, so it's only 14. If they ask header plus tail, then 18 bytes. If they ask what is the size of tail only, then 4 bytes. Okay. So it's a MAC address we are coming now. So I think we can now move to the this part, our packet tracer part. So there we can explain this topology, how actually the destination MAC address works.